Hey everyone. Okay, so today we're going to talk about linked list and how we use linked list in Swift. We're going to see different operations in linked list, like how to print a linked list, how to reverse a linked list, how to insert a new element, new node in linked list, how to get middle node of the linked list, how to remove the duplicate nodes from the linked list, and also how to find the nth node from the end of the linked list. Okay, so let's get started. So what is linked list? Linked list is a dynamic data structure. The number of data is not fixed like array, okay, and it can grow and shrink based on demand. So unlike array, linked list is dynamic, and we can add and remove data like nodes from linked list. So linked list node, each node in linked list consists of two things: data and link to the next node. So value and the link to the next node. Link to the next node means address to the next node. So over here we see, right, we have a header. Header will have, header is nothing, head is nothing but the first node, and it has data and next is nothing but address to next node. So data, and this is the address to next node, data, address to next node. This is how the linked list goes. A linked list is good if the number of insertion and deletion is frequent. So when do you go for linked list? You should go for linked list when you want to perform insertion and deletion from your data structure a lot, like your insertion and deletion is frequent. Then you should go for linked list, because unlike array, it doesn't shift each element by insertion and deletion. It just removes and add new pointer. So if you want to add new node over here, we'll just remove this pointer, and then we'll add new pointer to the next to the new node. Okay, so that's how it works. And linked list is worst if search operation is frequent. Okay, so you have to traverse through each element to search any element in linked list, and that is why it is worse. Insertion and deletion is time complexity for insertion and deletion is O1 and O1, because as I said, you can just remove and add new pointers, and insertion and deletion would be done. Whereas for searching, you have to go and traverse through the linked list. Okay, so that's why. So let's get it started. Okay, so over here, as you see, how do we create a linked list? Linked list is like combination of nodes, right? Linked list consists of a lot of nodes, so it's a list of nodes. So what does nodes contain? As I said, it contains the value and next address of the next node. Okay, so value in this linked list will have integer, and next will have address of the next node itself. Okay, and then we'll initialize it as we do it in Swift. So value, the way we initialize it, I'm sure you know this. Okay, so this is how we create a node in for linked list. And then so let's say my linked list is something like 1, and then 2, and then 3, and then 4, and then 5, right? So this is our linked list, and so the first node is 1. So first node value is 1, and next node is 2. So it holds the address of the second node. Same goes for second node, value is 2, holds the address of the third node. Third node, value is 3, hold the address of the fourth node. Fourth node, value is 4, hold the address of the fifth node, right? And fifth node will be pointing to nil, because it stops over here. There is no nodes ahead of it. Okay, so let's see, how do we print a linked list? To print a linked list, you have to traverse through the linked list, right? So in this function print linked list, we are passing our head node. So head node would be nothing but our first node, right? So we'll have first node as the head node, so we'll make it as current node, and then based on that current node, we'll write a while loop to loop through the each node, because the current node, the first node, will have address to the second node, right? And then second node will have address to the third node. So based on this scenario, we will traverse as long as current node is not null. So as long as current node is not null, we'll just print the current node value. So for first loop, it will be 1. Then we'll increment it. So current node will be incremented to current node dot next. And now the current node will point to second node, right? And then we'll print second node in the next loop, and then this scenario will be executed, and then it will point to third node. So it will go on, and our linked list will be printed like this over here in the console, as you see. 1 2 3 4 5 printing linked list as we have written over here. Okay, so this is how we print a linked list. Let's go and see how to insert a new node in linked list. So as we saw over here, all you have to do is to insert a new node in linked list. So in your, you will be given with, so your function will be given with the previous node and new value of the linked list, right? So you have to create the node. For the new node, you have the value of the new node, and you have previous node as well. So it means that you have to, previous node means, it means you have to add the new node after the previous node, this one, right? So over here is, as you see, we have to add a new node between B and C. So what we do, we remove this pointer. And how do we remove it? So for this new node, the value will have E, whatever value you want to give, and then address will be the address of this previous node. So previous node's address would be entered in the new node address, and then in the previous node will have address. In the previous node will have this node's address, like E's address would be in the previous node. So we are just exchanging the address, like this address will go here and this will go here. Cool. So let's see. So over here, where did it go? Oh, here, right? So if previous node is null, we'll obviously return it, because that's the position where we have to enter our new node. And then we'll create our new node. New node would be node with the value of new value, whatever value we are giving over here. And then next would be the as we said, right, the previous node. So let's say over here, this is our node, right? So this is, let's say 4 is the previous node, right? So 4, address of 4 will be entered as address for new node. Okay, so we are entering new node, let's say 7, between 4 and 5. So address of 7 will so in new node next, so for the next value of 7 new node, for this value of the new node will have 4, so the previous node's next value, so previous node next value, and then previous node next value will have new node, so previous node next value will have address of the new node. Okay, that's how you insert a new node. So over here you see insert node linked list. I have passed previous node as 4th node. Okay, and the value of new node I have inserted 4 only, so we'll have a duplicated linked list. 4 will be duplicated over here. So over here you see I have printed a reverse linked list. I'll show you how to print a reverse linked list, but over here you see we have 4 2 times, right? Because we entered 4 after the previous 4 value, so that's why we have 2 4s over here. Okay, let's see how to reverse a linked list. So to reverse a linked list, you should have head of the node, right? And then based on the head, we will reverse the whole linked list. So how do we reverse a linked list? Let's go back to our image. So over here, we'll see over here, right? So we'll have two more variables, previous and next. So we have 2 more, previous and next, and we have current node and the next node, right? So how do we, so previous node, for the head node, previous node would be null. Okay, so I have optional value. Both of these node are options, so it can be null or anything. So previous node is null and next node is also nullable, like optional. And then next should point to the uh, next node, like the current node's next. So for head, this thing would be next, yeah, like the next value, right? So so again we will be looping through the current node. Okay, so based on the current node, as long as the current node is not null. So in next will assign current current node dot next in the next, and then in current node next will have previous. Okay, so this is head, right? So once we so what we do is we just reverse these arrows, like these pointers will be reversing these pointers, and the null will come over here, null, right? So previous is our null. So for the last node, this will become our last node, right? So currently we have null in our previous. So current node or next will become null, and we have already assigned passed our current node or next to next. So this was just an exchange, like next will have current node or next, and next current node next, after it is assigned to next, the current node or next will become to null, the previous node. Okay, and then in previous node will assign current node. Okay, so the current node, this one, will go to previous, and then current node. So this is what we are just changing the arrow, right? So the previous node, it will have next, the next of previous node will be null, but the previous node will have this h value, right? So that's why previous node is current node, and then current node would be next node. So yeah, so next was what? Next was the current node or next, right? This one. So the current node will become this E. Okay, and then again we'll have the same. So what happened in the first loop? This array is now pointing backwards. Okay, and this next is pointing to null. Okay, and then in the next loop it will repeat the same process. Okay, now we are over here, and previous is holding the current node, this node, and current node is holding this node. Okay, so based on that we'll do, so our pointer will be here and this will be pointing backward, and then after the next, so again in the next we'll have current node or next. So the next will hold this element's next, so it will hold a, and then this element, this node. Okay, and then current node or next, so this node's next will be assigned with previous node, so this nodes. Okay, and then previous node will be the current node, so previous will become this node and the current node will become this node. So that's how we are just changing the pointers based on that. So this is a little bit confusing, but once you understand it, it will be easier for you. So yeah, and at the end we'll just return our previous node. Okay, because that will be our last node. So yeah, so over here if you see, I am printing reverse linked list, print linked list. I'm calling this print linked list function with the head node. So that's why it is printing the linked list. So first it was 1 2 3 4 5, and then it is 5 4 4 3 2 1. Why we have two 4s? Because we have added one in the insert node function, we added one more node, right? That's why. So that's how we reverse the linked list. Now let's see what is the next task. Let's see. Okay, next we'll see how to add an element, how to add a new, sorry, no. Next we'll see how to get the middle element. Okay, so how to get the middle node. So if this is our linked list, how to get the mid of this linked list, right? So what will the mid? 1 2 3 4 5 6. So mid of this linked list would be 3, right? So how do we do it programmatically? So there are two approaches to do it. First method is traverse the whole linked list and count the number of nodes. Okay, now traverse the list again till count by 2 and return the node at count by 2. Okay, so first thing is you traverse the whole linked list, and count the number of node, and then divide the number of nodes by 2, and then traverse again, and traverse till the half of the linked list, right? And then you'll have the node. So this is what we are doing. The current node is head, and then list length. So we'll check the linked list length. So this is being, so we have a function called get list length, and we'll pass the head node, the current node head node, and through which this function will get the length of this node. So over here I have this function get list length, and over here we are doing nothing. We are just traversing the same thing we did while printing the node linked list, right? Current node is not equal to null, then just current node equals to current node dot next, and then we just increment the count to count plus 1 and return the count. So we'll have the count over here, and then we'll find the mid of the linked list, right? So list length by 2 will get the mid of the linked list, and then we'll traverse again the whole linked list as long as it is it as long as it has not till mid node. Okay, till mid node. So this scenario will take you out of this loop as soon as you have reached till the mid of the loop, and then we'll just traverse like current node equals to current node now next, and then once we have reached to the mid node, we'll return the current node. So the current node will hold the middle node, and that's how we get our middle node. Okay, this was the method 1. So with method 1, if we check over here, get middle node. Okay, middle node by method 1, we are passing the head node. So after reversing the linked list, the head node is 5th node, right? So middle node by method 1 is 3. So we got the middle node by, which is 3. Okay, in this linked list the middle node is 3, and that is what we are getting. Now let's see the method 2. Method 2, that is very interesting method, and this is much more efficient than method 1. Okay, what we do in method 2 is traverse the linked list using 2 pointers, okay, and move one pointer by 1 and other pointer by 2, and when the first pointer, the fast pointer, reaches the end, slow pointer will reach the middle of the element. Okay, so we'll have 2 pointers, one slow pointer and one fast pointer. I have written slow node and fast node, that's fine. So we'll just so our slow node is head. We'll initialize both of these with head, the head of the current linked list, and then we'll traverse. So when we are traversing, the fast node will reach the end of the linked list when our slow node is in the middle of the linked list, because fast node is skipping one node. So it is like traveling by 2 nodes, like every 2 nodes, next to next. Okay, traversing by next to next, but the slow node is traversing each node. So when fast node will reach the end of the loop, end of the linked list, the slow node will reach to the middle of the linked list, and that's how we traverse. That's how we find out the middle of the linked list, and this would be much faster than the first method. Okay, so over here, while fast node is not equals to null, and fast node dot next is not equals to null, because fast node would be the one which will reach the end of the loop first, and that's why we are checking only for fast node. And by the time fast node is null, we will have the middle element in the slow node, and then we'll return our slow node. Okay, now we did talk about, we can see this over here, get middle by second method, and by second method also we are getting middle node, which is 3. Cool, so it is working. Now next we'll see how to remove duplicates from linked list. So over here, this is the method. So how do we do it? Let's see. So traverse the list from the head node. While traversing, compare each node with its next node, and if the data of the next node is same as current node, then delete that next node. Before we delete a node, we need to store next pointer of the node. Okay, so how do we delete duplicates from linked list? You just have to check for each node, you have to check the next node's value. If the current node value and the next node value is same, then we will delete the next node. Okay, and if it is not same, then we'll just continue. And also, while deleting, you have to store the pointer of the next node. Yeah, because that's how you delete, right? As I told you, you just delete the pointer and point it to the next node. So over here you see current node is head, and then temp next will have a temporary next node, and as long as current node dot next is not nil, will traverse our linked list. And if current node dot value is equals to current node dot next dot value, so if current node's value and next node's value is equals, then what do? We store the current we store the next node's address to the temp next. Okay, temporary next. So current node address will store in the temporary next, and then in current node next will add the temporary next. Okay, so it will skip the we are just skipping the next, the current node's next node. That's how we do it. That's how we perform the delete operation also. Okay, and if it is not same, then we don't want to delete, we'll just do our usual traversing. So this is how we like current node dot next. Cool. So this is how we remove a duplicate node from linked list. What you have to do is just check the next node's value, and if they are both equal, then you have to remove the next node. And how you remove it? You just point, like for current nodes next, you point to the current next node ka next. Okay, so current next node ka next will have pointer of the even further node. So let me just explain you a little bit more. So if you want to delete delete this, what we will do, we will, so this A has the address of B, right? So we will store over here, let's say our pointer is called temp next, right? So in temp next, in temp in temp next, we are putting current node dot next, right? This is the current node, and the next node is this, and in this next we are holding the pointer of this element. So we will store this address in temp next. This is what we are doing over here in this line. And after this is done, in the current node dot next, in this current node dot next will have temp next. Instead of holding the address of this node, now we'll hold the address of this node, which we already passed in the temp next. So this address will go in this, like directly. The P's address will be A in the A's E node. Okay, I hope now you understood. I hope now I am also convinced. So yep. Okay, so yeah, so over here, let's see, remove duplicate from the linked list. We have removed. Okay, we pass the head node as the fifth node, as we have reversed it, right? And then print linked list. So if we print it after removing, okay, over here you see remove duplicates, and if we print it now, we don't have 2 4s. Over here we had 2 4s, duplicate 4s. Over here we have only 1 4. So it is working. Congratulations. Okay, next excuse me, next we gonna see how to find nth node from the end of the linked list. So what we have to do, we have to find the nth node. So let's say this is our linked list, right? So I want to find the second node from the end. So second node from the end is 4. So that's all. So how can we do it? So there could be two approaches. I will over here I'll show you only one approach, but I'll tell you what are the two approaches. First approach is you calculate the length of the linked list, uh, okay, and then let the length be len, okay, and then print the len minus n plus 1 1th node from the beginning of the linked list. So uh, you calculate the length of the linked list and then traverse to in the linked list till len minus n plus 1. Len minus n will give you the number of time you should traverse to reach the node which you want to get from the end of the linked list, right? That's all. That's simple maths. Second approach is again the same, like the logic is same, but we are doing it in different way. So again we will have two pointers. We'll call it reference pointer and main pointer, and initialize both reference pointer and main pointer with head, and first move reference pointer to the end nodes from the head. So let's say you want to move till you want to check second node till the from the end, right? So you should traverse for reference pointer till second node from the beginning, okay, and then now move both the pointers. So once your reference pointer has reached to the second node, to the nth node, whatever nth node it is, then you start your main pointer as well, okay. And when your reference pointer will reach to the end of the linked list, your main pointer will reach to the nth node, okay. So let me just show you in this. So over here, let's say we want to find out the second node. Second node is A, right? So over here we want to figure out the second node from the end of the linked list. So what we'll have two pointers, reference pointer and main pointer, and then we'll run our reference pointer to the number of to the nth time. Nth time is the number of times we want the nth element from the end. So we'll run it to two times. So first time it will reach to the head, and then second time it will reach to the second pointer, right? So the reference pointer will be at this position. It will point to this node, okay, and our main pointer is still pointing to the header node. Okay, so first we'll initialize our main and header reference pointer with head only, the current node. And if you run it for two times, the reference pointer will point to this node. And then main pointer, will run the main pointer and reference pointer together then. First you run the reference pointer only and reach it to the nth node, and then you run the main pointer and run it until your reference pointer reaches the null. So in the first time, this will reach P over here in this, and this will reach over here, and then next time this will become null, and this main pointer will point to this element, and this is what we are looking for, right? So same goes. So over here we had this very small node linked list, but in the big linked list it will be very helpful. So I hope you understood. So what you do is you have two pointers, reference pointer and main pointer. You can call it anything, and you run your reference pointer to the nth node from the beginning, and then you run your main pointer and reference pointer together until your reference pointer has reached to the null. And once your reference pointer has reached the null, it means your main pointer has reached to the nth node, and you have in main pointer you have the nth node, and then you can return the main pointer. So this is what we are doing. So as long as head is not null, we have two pointers, main pointer and reference pointer, which is pointing to head, and then we have a count also So over here, as long as count is less than n, so we have to traverse the reference pointer until it has reached to the nth node, right? So if reference pointer is not null, then we traverse the reference pointer to the point to the next reference pointer and count and increment the count equal to count plus 1, and as soon as soon as it reaches to the end pointer, we'll come out of this loop. Okay, and now at the end of this loop, reference pointer uh, pointer will point to nth node. Okay, from beginning, not from ending. Okay, but what we want the reference pointer from the ending, and that's why we will again run the reference pointer till the end, till it is not null, and this time we'll also run our null main pointer. So when reference pointer reaches null, then it means that our main pointer had reaches the nth node. So this node will be the nth node uh, from the end. So at the end of this while loop, main pointer will have nth node from end. Okay. So over here you can see find nth node from end. We have passed fifth node and we want to check third node from the end. Okay, so nth node value, so double question mark, I hope you know it means that we are passing some default value, and then the nth, the third node from the end of this linked list is nothing but 3. So that's what we are getting. Okay, so these were all the operation I wanted to cover in this today's chapter of linked list. I hope you liked it. If you have anything, if you want me to cover anything else also in linked list, I'm planning to have one more chapter on doubly linked list also, because some companies ask for doubly links as well. So we'll see. We'll see you in the next video with doubly linked list then. Okay, cool. Thanks for watching. Bye bye.